In this video, we're going to look at linear models, and we're going to look at linear models with some real data. We're going to also be reviewing the point-slope formula and the slope-intercept form of the equation of the line as we go through these examples. So let's go ahead and dive right in with the first linear modeling example. We've got these Chelan County total COVID cases. These are cumulative numbers below, and we're going to compute an average rate of change. So let's see. So we've got this day one. So first of all, day one represents for Chelan County, that was the 16th. We want to find the average rate of change, and we're going to graph the data, and where is it linear? Well, let's start by finding the average rate of change. That's going to be over the entire period. So the average rate of change, so the rate, is going to be equal to the change in cases over the change in time. In this case, time is days. So over the entire time span, it's 1536 minus 1. This is the change in cases, 1536 minus 1, divided by my days, 150 minus 1. I can put this into my calculator using parentheses around the numerator and denominator. Okay, I think I can get it there. There we go. So let me clear what I've got here. I can also just do 15, let's see, so that would be 1536 minus 1, that'd be 1535, divided by, we'll just keep it easy, 150 minus 1 is 149. I got that. Okay, so that's going to be about 10.3. So my average rate, so my rate sub AVG is going to be, I forgot already, 10.3? About 10.3. And this is cases per day. This doesn't tell the whole story though, because there are times over these 150 days where the rate is increasing pretty quickly and other times where the rate is slowing down or maybe even negative. We're going to graph the data in Desmos and then decide where the graph is most linear. So let me open up Desmos and I'll put that in a different desmos.com. Put that in a different viewing window. And just make some room for us to work. Okay, so the first thing I want to do is to put this data into Desmos. So I want to click the plus sign and I want to add a table. So I've got my X's and my Y values. So I'm just going to do 1, enter 30, 60, 90, 120, and 150. And let's do the same thing with our Y values, the total cases, 165, 176, 275, 656, and 1536. I do have the graph over here. Make it big here, but it's hard to see, right? I only see a single point, and that's because I'm going from negative 10 to 10 in the X direction and about negative 6 to 6 in the Y direction, but my X's go from 1 to 150. My Y's go from 1 to 1536. So I'm going to change the settings by clicking on this wrench, graph settings, and I'm going to go down here to the Y-axis and X-axis intervals. For the Y's, I can just start at 0. So I'm going to go from 0 to, let's see, 1536. Let's go up to 1600. Oh, wait, these are the X's. So 0 for the X's, we want to go up to 150. Let's just go up to 160 maybe. And now let's go over to the Y's. So for the Y's, we'll also start at 0. And let's go to tab over. Now let's do the 1600 here. 1600. Just so long as you grab all of that data, and then we'll click here. So if I'm looking to see where this is linear, and I can move it around a little bit, it looks pretty darn linear between these 3 points right here. We do have a different slope here, but these 3 look like they're linear. And then we have a change between these last 2 points, between days 120 and 150. So it looks like it's pretty darn linear between days 30 and 90. Let's see, this was 90 and 120. So between 30 and 90. Okay, so let's go back to this. Okay, where is it linear? And it's going to be days. So this is actually a domain interval. So I'm going to do square bracket 30 to 90. What is the average growth of cases per day during that period? So I want to grab the point at 30 and the point at 90. So again, to find this rate of change, I'm going to do the change in cases, total cases, divided by the change in days. Y2 minus Y1. So that's going to be 275 minus 65 divided by 90 minus 30. Make sure that your points line up so that they're up above one another. Okay, so I'm going to do parentheses 275 minus 65, parentheses, divided by parentheses 90 minus 30, or you can just call that 60 in your denominator, and we get 3.5. This is a meaningful number, right? So equals 3.5. 3.5 what? Cases per day. Cases per day. So during that time period, let me grab Desmos again. Is it this one? Yep, there it is. So during the time period between days 30, that would be about April 16th, and 90, we're increasing at a pretty steady rate of 3.5 cases per day. Okay, back to the worksheet. Now we want to find a linear model for the number of cases per day during this time period. Well, this 3.5 that I have is the slope. I also have a couple of points, right? So the points that I've got are these here. I can change this into the point 30, 65. And the other point would be 90, 275. If I want to use the point slope formula to find that linear model, another name for just equation of the line, I can use either of these points. I'm going to grab the first one. So I'm going to use my point slope formula. Y minus y1 equals m x minus x1. And for my point, I'm going to use 30, 65. So as I put this into my model, y minus y1, which is 65, equals m, that's my rate of change, 3.5, x minus x1, and that's 30. I need to distribute that 3.5, so y minus 65 is equal to 3.5x minus 30 times 3.5. 30 times 3.5, 105. I just need to add this 65 to both sides. So I need to do negative 105 plus 65, negative 40. This gives me my, my equation. I'm going to write it in terms of y just to start. Y is equal to 3.5x. Is that 35? No, 40. Such a short-term memory. Minus 40. I should know better. Okay, minus 40. But I really want this in terms of cases per day. X represents my days, and C represents my cases. So D is the X, and cases is the Y. Let's do this final answer in another color. So this is going to be C, or C is a function of X. C of X is equal to 3.5. Actually, we're not using X, are we? So C of D is equal to 3.5D instead of X minus 40. Okay, next. Estimate the total cases on May 1st, which is about day 45. So if I'm estimating this at day 45, I want to let D in my model equal 45. So I'm going to go ahead and grab my model. C of 45 is equal to 3.5 times 45 minus 40. Let's grab the calculator. 3.5 times 45 minus 40. And we get 108.5. So I'm going to write this in green also. So 108.5. 0.5 what? 108.5 cases. This is day 45. So I could actually add a day right here, day 45. And we had what? 108.5. And it does line up nicely, doesn't it? 108.5 cases. Okay, next. How much did the cases grow in May, which is between the days of 45 and 76? Well, the model that we have right here in green is good for the days 30 to 90. We're being asked about days 45 to 76. So I can go ahead and figure out, using my model, using that rate of change, how much the cases grew between days 45 and 76. We know that they grow. Our rate is 3.5 cases per day. So if I just know how many days are in this time span of May, I can figure it out. So I'm really looking at a total of 31 days. So to figure out the number of cases, I'm going to take 3.5 cases per day and multiply that by 31 days. Look how nicely the units work out here. We're going to end up in cases. So I'm going to go ahead and take 3.5 and multiply that by 31. And we get, well, we've done that one before, 108.5. Again, that's just a coincidence. Okay, so 108.5. Okay, so we were able to use just the rate to figure out by how many the cases grew during that time frame. Interesting though, because the total cases May 1st was 108.5, and then it grew another 108.5. It's doubling in that time. So another just sort of interesting way to take a look at what the information is telling us. Okay, number 2. In number 2, the minimum wage for Washington State in 2000 was $6.50. In 2020, the minimum wage is $13.15. We're going to assume that the minimum wage grows linearly. We're going to find W in terms of the years since 2000, T. So let's go ahead and just make ourselves a little grid here. So this is going to be year 2000, year, and I'm going to put another one, years since 2000, since we're really asked to do it in terms of that. This is going to be our T. And then the last one is the actual wage. So in the year 2000, the wage was $6.50. And at that point, we were 0 years since 2000. In the year 2020, the wage is $13.50. And we are now 20 years since 2000. So these are my points. So if I go ahead and just wrap some green parentheses and commas around these, I've got myself 2 points. The first variable is T. The second variable is W, that minimum wage. And I can go ahead and use a point slope formula to find the equation of this line. The very first thing that I need then is M, as always. So M is equal to the change in this case, W, over the change in T. So we're going to do W 1350 minus the initial W of 650 divided by 20 minus 0. 1350 minus 650, that's 7. So in my calculator, I want to go ahead and take 7 and divide that by 20. And we end up with 0.35. This is how much minimum wage increases per year. So it seems like a really big jump between 2000 and 2020, but actually it's just 35 cents per year. So it's not a huge increase. Okay, so 35, so M is 0.35, 35 cents per year. Now we've got two choices. I mentioned using the point slope formula, which would work. But if I take a look at this first point, this one, it is a y-intercept. So instead of using, I do this in green, instead of using the point slope formula, I'm ready just to throw this into slope-intercept. B is equal to $6.50. So let's go ahead and throw this into slope-intercept form. Y equals mx plus b. In our context, y is w, equals m, that's my rate of 35 cents, 0.35, x is t, plus b, which is $6.50. I wrote w. You could also express that as w of t. Predict the minimum wage for the year 2030. T, remember, is years since 2000. So in 2030, it's been 30 years since 2000. So I want to evaluate my function w at 30. So we're going to do 0.35 times 30, goes right in there for t, plus $6.50. Okay, I'm going to grab my calculator. So 0.35 times 30 plus 650. So $17. So by the year 2030, we should be up to a minimum wage of $17. Okay, number 3. The 2020 average salary for a civil engineer in Washington State is $93,816. In 2016, the average was $89,730. And these are actual numbers based on the U.S. Bureau of Labor Statistics. At what rate is the average salary increasing? So this is a rate, also known as a slope. So M is going to be the change in salary over the change in time. Change in salary, so 93,816 minus 89,730 divided by the change in time. 2020 matches with the 93,816 minus 2016. Put some parentheses because I'm going to put this into the calculator just like this. I'm just finding the slope. So I'm going to do parentheses 93,816 minus 89,730 parentheses divided by parentheses 2020. Oh, darn it. One more time. 93,816 minus 89,730 parentheses divided by parentheses, and now I'll do 2020 minus 2016, which is just 4. I could have done 4 as well. Making sure I've got my values in there correctly and it looks good. So there's a change of about $1,000 per year, $1,021.50. So $1,021.50 per year is the average salary increase. If this trend continues, what will the average salary be in 2025? So we're increasing about $1,000 per year. I need to get from my salary in 2020 plus 5 more of these increases. So 5 years, I'm going to go 5 times $1,021.50. So let's see. I've got that as my last answer. So let's go ahead and just do times 5 right here. So my salary is going to increase $5,107.50. And that's from the 2020 salary. So we want to do this answer plus 93,816. So we get 98,923.50. 98,923.50. So I'm going to take this increase. This is my 5-year increase, and I'm adding it to my 2020 salary. And then just to make sure I got that right, 98,923.50. Great. Okay, find a function that represents the average salary A as a function of years since 2016. So again, if I do year, and I do years since 2016, and then I do salary, I've got 2016, years since would be 0, and my salary is 89,730, 89,730. 2020 is my other data point that I was given, so it's a nice one to use. This is going to be 20 years since, oh no, not 20, 4 years. And that is a salary of 93816. Well, to find a function, my very first goal is to find M, which is my rate. I've already done that. That's this guy, equals $1,021.50 per year. I'd love to use y equals mx plus b, and to do that, I need a y-intercept, and I have a y-intercept. So that is b. Let me put this in green. So this is b right here, which means that I am ready to go ahead and just put my equation together. I'm going to do this in terms of x and y first, and then I'll put it in the correct variables. So y is equal to m, which is 1,021.5, x plus b, 89,730. But y is my average salary. So a times t of t is equal to 1,021.50 times t plus, this is a plus right here, plus 89730. And that is my function with salary as a function of time.